Okay, start recording. So from our previous rules, okay, we already cover up to rule 31. Okay, rule 31 substitution. Okay, is a integration technique. Okay, so I hope that you already done with the exercise 6F. Okay, from the exercise 6F, you are welcome. And if you don't know how to do any questions, okay, please remember that you actually can send your questions to me. Okay, so this is the rule 31, the technique. So we continue. Okay, maybe it's been a while that you've forgotten what have you done previously. So let's try to visit all again. Okay, what have you previously done? Okay, about the integration. Okay, let's see. So over here previously, okay, let's see. We already done with the basic rule. Okay, section A, basic integration. Section B, okay, section C, rule about trigo. Okay, section D, advanced formula. Okay, what else do we have? Okay, after section D. Okay, so now the next one we want to cover is from, okay, then after that we have, okay, section E, special formula. Okay, section F. Okay, until the last one that we did is by substitution. Okay, we stop here. Okay, now we have to continue with the rule 32 by parts. Okay, 33 and continue. Okay, until rule 40. That as you can see from here. Okay, until rule 40. So let's continue with rule 32. Okay, rule 32. So 32. 2. Okay, in the integration by parts. Okay, so what actually happened is for this integration, you have two items that being multiplied together. You have a u and v prime. Okay, you have a u and v prime. So you have two items, the u and the v prime here. It can be anything. It can be x power n. It can be trigonometry. It could be log. It could be trigo. Okay, any combination. So if you have two items that multiply together like this, we actually can change it into ux, vx minus u prime x, okay, vx dx. So that this is what it means by parts. So we actually tackle them parts by parts. Okay, so this is a formula. For although that there are two items that are being multiplied together, but there will be some students getting confused like, I have two items here. How do I know which one to do as you recognize as u, which one to recognize as a v prime? Does it mean the one in front always read as u? Okay, it doesn't work like that. Okay, there is a rule how to actually recognize the u. And the order to choose u. Okay, so we'll follow this order. The first one will be inverse trigo. Okay, second ln, trig, ln poly, trigo, exponential. Okay, we'll follow this procedure. Inverse trigo, ln, poly, trigo, exponential. So in your P3, the only inverse trigo that you learn is arctangent. So if you have an arctangent, that means you have to choose arctangent as your u. Okay, so this is how we do for order to choose u. Okay, so now let's try to look at the example of question. So example, Okay, for example, like let's say I have x ex. Okay, x ex, how do I actually apply the formula here? Okay, how do I actually apply this formula? So from x and ex, okay, following the order, we will choose, okay, u equals to x, v prime equals to ex. Then u differentiate, I have 1. V, I integrate, I have ex. You don't need to write plus c here. So according to the formula, you will need to use these 3 components here. Then according to the formation, okay, you have a x times ex. So okay, u times v here. So x times ex minus integrate of the u prime times v. So u prime times v. So 1 times ex. So ex here. Then after that, okay, so you have a x ex minus ex plus c as your answer. Okay, so this example is one round by parts, one time by part. Okay, if I say like this, so that means you have a multiple time. So you may have a questions that 2 times by parts. Let's see. Okay, let's say I have x squared with the sine x. Okay, x squared with sine x. So over here, from the x squared and the sine x, following the order on how to actually choose u. So we will choose u as x squared. Okay, I will choose v prime as sine x. Then my u prime will equal to 2x. My v will equal to negative cos. So I need to use these 3 components. So I write them up. So u and the v, I have a negative x squared cos x. Okay, minus become plus of integrate of 2x cos x dx. You will notice that, hey, the integrate of 2x cos x, I still have something left behind. Okay, still multiplication of 2 things here. So that means I will need to do by parts for the second round. Okay, I need to do by parts for the second round. So when I do by parts for the second round, so I let u equals to 2x. Okay, v prime equals to cos. Okay, u prime equals to 2. V equals to different integrate of cos go to sine. Okay, so I need to use these 3 components. Then from here, of course, the front part, the negative x squared cos x is already done. Okay, then you have the following part. So you have a 2x and the sine x, so you have 2x sine x. And u prime and this will have a minus or integrate of 2 sine x dx. So I have a negative x squared cos x plus 2x sine x. This one integrate sine go to negative cos, so you have positive of 2 cos x plus c. Okay, so this example is 2 times by parts. 2 times by parts. Okay, of course you have 1 time, 2 times. Okay, of course you can have 3 times, 4 times, and so on. But another type of important example is a loop questions. Okay, no ending. No ending. This is the part that students should be careful. Okay, so let's say the example is ex sine x. Okay, so from here, from the long polytrigo E, so I shift take as a sine x, my v prime take as a ex. So my u prime goes to cos x, my v is still ex. So I use these 2. So I will have a ex sine x minus integrate of ex cos x. So as you can see from here, I still have multiplication of 2 items. So I still need to do it further. So I let my u equals to cos x, my v prime equals to ex. So my u prime equals to negative sine, my v equals to x. So I still using these 3 components. So I have ex sine x minus, okay, put a square bracket here because you have a negative sign outside. So we write them properly. So you have ex cos x, then minus of, then by the way, minus minus become plus, ex sin x. Then from here, okay, open up the bracket, ex sin x minus ex cos x, okay, minus of integrate ex sin x dx. You realize that, hey, this ex sin x and integrate ex sin x is the same thing again. Does it mean I need to continue forever? This is what I meant by the loop, okay? So there is a closed loop that you can actually observe. Since this one is minus, okay, I can shift this entire thing to the left side. I have 2 times of ex sin x. That actually gives us ex of sin x minus cos x. Okay, so bring the 2 over to the other side. You have ex sin x dx equals to 1 over 2 ex and sin x minus cos x plus c. Now finally you can put a plus c because that's the end of your integration. Okay, so then please observe there is a sin x minus cos x here. Sometimes based on the question, they may be asked you to write it in the different form. So the question may be appear as a square root 2 of sin x minus pi over 4. Okay, what is this thing? I hope that you can remember. This is your R alpha. Okay, this is your R and alpha from your trigo. I hope that you remember this part. Okay, I hope that you remember this part. So please understand that again, I have already highlighted for many times, your chapter 1, 2, 3 is actually very, very, very important for your remaining topics for your P3. Okay, so as you can see, the trigo thing, okay, or the algebra or whatever, is keep appearing again and again and again. Okay, so this is the loop example. So then from here, there will be some special formula that we have yet to discover. Okay, special formula that we have yet to discuss. From that, if we refer back to the special formula with proof, okay, so 24, 25, and 26, we haven't done it yet. Okay, 24, 25, 26, we haven't done yet. Let's go back to 24. So the proof for 24, okay, integrate of sine square. Of course, from the previous, you already shown that this sine square can be done by using the trigo way, okay, the section C way. Okay, but this time we want to look at what happens if I use the by parts. So I have a sine x times sine x here. Okay, so since I have a sine x times sine x, so I let my u equals to sine x, my v prime equals to sine x. So my u prime equals to cos x, my v equals to negative cos x. So I use these 3 components. So I have a negative sine x cos x. Okay, minus minus become plus of cos square. Okay, so over here I can see there's a cos square. A cos square, I can actually use our trigo identity. Okay, and write it in the form of 1 minus sine square. Okay, according to integration rule as well. Okay, we can separate this 1 and the sine square become x minus integrate of sine square x dx. Now you can see that they are the same item, so they can join together to sine square x dx equals to x minus sine x cos x. You can see this x, I just shift it in front, so bring the 2 over to the other side. I have a 1 over 2 of x minus sine x cos x plus c. Okay, rule 25, which is cos square x dx, that actually gives us 1 over 2 x plus sine x cos x dx is actually using the same process as 24. Okay, we are using exactly same process as 24. Then 26, integrate of ln x here, integrate of ln x. So you may be surprised, this ln x seems like it only have one thing. Okay, so how do we actually use by parts? By parts we supposed to have two items. Okay, because a ln x itself is actually just one item itself. So we read it as 1 times of ln x. Okay, we read as 1 times of ln x. So according to the order to choose u, ln polytrigo e, okay, so my u I will choose as ln x, my v prime it choose as 1. So my u prime goes to 1 over x, my v goes to x. Then from here, okay, so the u and v together, so I have x ln x, then minus of 1 over x times x dx. So x here can be cancelled off, x ln x minus integrate of 1 dx. So integrated x ln x minus x plus c. Okay, so this will be your rule 32. Okay, rule 32, the second technique. Okay, integration by parts. So to help you understand better, it's better to let you do the exercises. Okay, so we shall look at the questions that help you to understand better for integration by parts. Let's see. Okay. Let's look at the questions. I will crop the answer as well. Okay, so this one, okay, we will do up to here first so that you can actually understand things better. Okay, let's look at the questions. Okay, this is your exercise. Okay, this is your exercise. So now please remember that we already done. Okay, if you go back to the rules, we already done with, finish with A, then finish with B, then finish with C, finish with D, E, F. Okay, now we stop at 32. So we have still have 33 to 40. Okay, to the leftover. So not going to rush you. I'll let you do the exercises first. Okay, so that you actually can understand the things better. And something that you need to remember, your P3 will be focused on integration technique questions. Okay, so when that means F. So which means when you do F, we already expected students to know how to do A, B, C, D, E. Okay, we already expected students know how to do A, B, C, D, E. So that's all. I will stop recording.